bandwidth and network architecture you have today. So what I want to start out with is just more around what WAN acceleration technology does today and why companies are looking to utilize and roll out WAN acceleration. A lot of this stems from the fact that WAN acceleration can improve things like business applications. It can improve the response times to critical internal applications that may be housed at a corporate location, potentially even a data center in certain cases, depending on the type of traffic or application the users are looking to utilize. The other great thing about utilizing WAN acceleration is the ability for it to reduce, or the technology to reduce bandwidth consumption. So a lot of companies have limited bandwidth outgoing either to the internet, or they may have a dedicated circuit which has a lower bandwidth consumption than their actual internet pipe. And so utilizing WAN acceleration technology can actually reduce that overall burden on that WAN circuit. And also, it can reduce the associated bandwidth costs. A lot of people that I've talked to just say, well, you know, I'll throw more money at the problem, I'll increase my bandwidth to, you know, X, Y, or Z, and that'll solve the problem. In a lot of cases, that won't, and I'll explain why here as we get further along in the presentation of some of the challenges with just throwing more bandwidth at the problem. But the idea here is that we want to make the network appear faster, the network faster for those remote and branch office employees, and make sure that they're more productive. Perception is reality in this case. If they complain that the network is slow, that is going to be the reality for the connectivity that they're experiencing from those remote and branch offices. If you look at some of the needs of why companies are looking at, you know, WAN acceleration technologies, if you look at branch office, you know, connecting back to corporate office either via a VPN or MPLS link circuit, a lot of the challenges that companies have today is the, you know, outpaced growing bandwidth requirements, meaning that the bandwidth requirements that companies have today, especially around their branch offices, are really outpacing, for two reasons, the capabilities of their internet circuit. That could be one of two things. Either a cost justification is not there to improve or increase the capability or speed, or a second could be a physical limitation to the actual circuit going into that remote or branch office, meaning that the telco or the service provider may not be able to improve physically the current bandwidth that's available there. Other technologies that I've seen people say, oh, well, you know, I'll just throw QoS at the problem, right? And QoS in its nature is really around a protocol level solution, which is really ineffective at being able to identify different applications that are flying by. The other challenge that comes into play here is around application latency. A lot of the applications that companies use today were really designed to work on a local area network where the latency was a lot lower. And so the challenge with that is as soon as you go across the internet or across an MPLS circuit or across some WAN connection that increases the latency, the applications become more sluggish, the performance is a lot worse, and again, this is where the users actually start complaining that the network seems a little bit slow. And then finally, the ability for us to reduce the overall traffic that's consuming bandwidth, meaning that the redundancy of the traffic, if we're seeing the same thing over and over again, that can be reduced by using WAN acceleration technology as well. If you look at the two methods that we're talking about today from SonicWall, it's really a twofold solution that we're talking about. The first one is the ability for us to do traffic shaping, which is the ability for the network administrator to prioritize what is good versus bad, or what I like to refer to as what is business critical versus not. And so through our SonicWall next generation firewall technology and our application intelligence and control, network administrators can write policies that can actually get to what is good versus what is bad. From there, then we can take, after the traffic has been, you know, we got to the good traffic, we can then do more of what I refer to as the WAN acceleration or WAN optimization technology. So we can do things like deduplication, so we can remove redundant data. We can do protocol optimization, where we can, again, trick and improve the application latency in certain cases, so we can actually improve the end user experience. through a lot of different WAN acceleration techniques.
This is Nate, and forgive me for interjecting here. If you can go back to that previous slide, there's a question that came up from the audience about, such as with regard to a line of business application, if a company has a hosted platform, can you give an example of how the application intelligence control piece, the prioritizing the good versus the bad, what that might mean relative to something like a line of business application like using Salesforce.com or some other hosted program versus just other internet traffic? Can you elaborate on that a little bit for the audience?
Sure. So for this part of it, when I'm referring to more of the app intelligence control, more of the traffic shaping, what that means is that we can prioritize bandwidth to what I refer to as business critical applications. That could include something that's hosted offsite like Salesforce.com, for example. You could actually go in and write a policy that gives that specific application higher bandwidth, either for all users, or you could do it for a specific set of users within the internal network, where you can say, Salesforce.com, my sales guys that are sitting here get higher bandwidth to go out and utilize that, whereas if you didn't have this, then all of the traffic would get the same equal footing as it's going out. As I explained it to people, so that would be one example. The other example would be, well, I don't want my sales guys to use, streaming video applications. So for Salesforce, you give them a higher bandwidth priority, but for something like streaming audio or streaming video, you might say, I'm going to block these specific users from accessing that type of application. That's what I'm referring to when you say good versus bad, is the different types of business critical applications that we can prioritize and give different levels of bandwidth control, or even outright block certain applications from being utilized.
And to clarify on that point, and this is one thing, because we're talking about these two technologies, that particular functionality that you were just describing is independent of multiple locations, right? That is something you do at the respective location level. So even an organization with just one location can leverage that technology.
That's correct. And I'll cover that a little bit further here on the next slide as we start talking about kind of the high-level vision of what I'm talking about. So as part of the first component, as Nathan mentioned, when we start talking about traffic shaping, this can be done on any one of our next-generation firewalls all the way down to the lower-end T10 platform. What it provides is the ability for us to identify at the application level what's going on the network, provides tools to visualize the traffic that's going by on the network, then provides the control so the network administrator can then go back and prioritize different traffic based on the policies that have been put in place by that specific organization. So they can do things like, prioritize business critical applications like Salesforce. They can block specific applications like video streaming or other types of P2P applications. That's a couple of examples. Today we roughly have about 3,500 different application use cases that are preloaded onto the system. They're categorized, I believe, in about 56 different categories, or about 50 different categories, where you can look at it and say, I want to block all P2P applications. You can look at things like IM. We can block different IM programs like Yahoo or MSN. We can even block specific use cases within a specific application. So for like Yahoo IM, as an example, we can go ahead and we can allow the chat to take place between two Yahoo IM clients. We could actually block the ability for somebody to send a file between the using that IM program. So there's a lot of different use cases that administrators are utilizing the app intelligence and control. And again, it's not port and protocol or at a port and protocol level. It's actually at an application level. The biggest challenge that we see today is that port 80 is no longer just for web traffic. Port 80 is actually what I refer to as a transport port where other applications can utilize port 80. So the ability for our next generation firewalls to actually be able to scan at the application level and inspect the payload is really, really important to be able to get to the ability for us to scan at that level and be able to provide the controls, the tools to allow administrators to go back and say, no, I don't want to allow this, or yes, I do, and this is the bandwidth priority I want to give to it. The final thing I'll leave you with is that we can tie it back to users. So I've had a lot of questions about, what type of user capabilities do we have? Well, we have the capability to utilize a single sign-on functionality that will allow us to uniquely identify the users logged into the network. And then from there, the network administrator can use that information to either block the application to user or to user to application. And so there's a couple of different ways that we can uniquely identify the who and the what that we do want to provide the bandwidth management and the controlling of the different applications in use here.
So a question from the audience, I think you just answered one of those based on the user restrictions and the single sign-on. But a common, and I think you were alluding to some of this earlier, but the question was around Facebook and how oftentimes there's a business case for people using Facebook, but yet there may be other aspects of Facebook that like games or other the applications that are kind of embedded in Facebook. Are there some granularity there that an organization can help lock down as well?
Yeah, so for that specific use case, we could, we could basically say marketing gets to go to Facebook and everybody else doesn't, as a high-level example. We could even take it so far as we could allow people to get to Facebook to do certain things, and those could be, as an example, we can allow them to go to Facebook and post something, but we won't allow them to play the game Farmville, as an example. So we have a lot of different widget application signatures built into this that would allow you to go back and look and say, okay, I don't want them to do this, 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 and this on Facebook, but they may be allowed to do these other types of things on Facebook. Or I could tie it back to a specific set of users and say, the marketing group or Matthew Diekman is allowed to get to Facebook to do whatever it is he needs to do. So there is some granularity there, definitely, to provide the controls over those different applications in use.
Great, thank you.
All right, so once we get, once we've received or gotten to this good traffic or the concept of good traffic, then we can provide the acceleration. So from here, now we're talking about the ability for us to do things like deduplication, where we're actually not sending the entire file or the entire set of data across the network between, your remote and branch offices. When you're using things like collaboration, sites, SharePoint, you're sending files back and forth. Traditionally, what ends up happening is that you have small localized file changes that happen. And in most cases, what the network will do is it'll send all of the entire data stream across. So if you have a 20 meg file, you make one small change to it, you remove a slide or add a slide, basically that entire 20 meg file will be sent across that network. And so what we're talking about here is the ability for us to reduce the amount of traffic that is actually sent between the various offices. The benefit of this is really to reduce the redundancy of the traffic, improve the responsiveness time, and improve the actual end user experience as well. And I'm going to, if time permits, I'll show you guys just a quick demo as we get to the end of this afternoon's presentation that'll kind of show you exactly what I'm talking about when we refer to being able to reduce the amount of data going back and forth. I don't want to spend too much time on this part of the presentation, but again, this is where we introduced the SonicWall WXA series, and it's an extension either via software or hardware for our next generation firewalls. It provides all of the WAN acceleration technology. It plugs directly into the NGFW, either via one of the dedicated interfaces on the devices, again, either a software or hardware. The two software variants of WXA 500 and the WXA 5000. One is an ISO image that's bootable from pretty much a low-end PC. The virtual appliance is meant to run in an ESX environment. For those of you that like more of the hardware form factor, we do also then have the WXA 2000 and 4000, which are physical hardware appliances that you would purchase in that case. The difference between the various platforms that we have is just really scalability. So meaning the number of users and the number of connections that the devices can actually support. So if you look at the chart, and again, I'm not going to go through the entire thing, all of this is in the data sheets and information on our website. The concept is for a lower end network where you're running TZ or lower end NSAs, you might want to look at a WXA 500. When you're looking at some of the mid-level NSA products, maybe into the WXA 2000 and 4000, and for some of the higher end, you may want to look at the virtual appliance. So there's, again, a lot of different options that we have available as it relates to WAN acceleration specifically. The key technologies that we utilize, and I've kind of hit on this a little bit, but the ability for us to do protocol optimization, so meaning that what we can do is reduce what is referred to as the round-trip time that it takes for a packet to traverse the network. what we're doing here is reducing the latency that would be introduced. You know, if you think back to what I said earlier, a lot of the applications were never designed to run a wide area network. So in the protocol optimization case, we can reduce the amount of time that it takes for that traffic to traverse from one location to another, ultimately reducing the latency, ultimately improving the end user experience. For the Windows file sharing acceleration, again, for this, we're actually doing file caching and metadata caching in this case. And so what we're doing here is the ability for us to cache locally a lot of the data that the employees at those remote and branch offices might have, so that they don't have to go all the way back to the corporate office to access those specific file or those specific resources. And finally, byte caching and deduplication. So in this case, what we're doing here is we're actually creating a copy of the specific file, of the specific traffic that's going by. What we're doing is we're creating the information as an ID, and then we're adding that to the database on the WXA platforms. In which case, if we see the same data, we'll basically not send it across the tunnel or across the MPLS circuit. We'll only send that ID, and then that traffic will be reassembled on the other end. And so in this case, what we're actually doing is reducing the latency, improving speed, and also reducing the bandwidth consumption as well that's going to take place between these remote and branch offices. From a deployment standpoint, there's a couple of ways, as I've talked about, that the WXA solution can be deployed. The first one would be utilizing a site-to-site VPN, where you have a corporate office with a bigger sonic wall firewall, and you've attached WXA, in this case 4000, to it. A lot of the data is residing here as well, so all the file servers, all the web server applications. And then you have multiple client locations out in the field that have either bigger NSA platform or even TZ platform devices where a WXA appliance would be directly attached to them. It also works through an MPLS circuit as well. So there's a lot of questions where people have asked me, well, what if I have a dedicated circuit? Can I do the same type of thing? So yeah, you could, again, have a bigger sonic wall, corporate office, attach a bigger WXA. At the remote offices, you again, put out one of the lower-end NSA platforms, one of the WXAs, connect it up, and then route the traffic through the MPLS circuit, and still achieve an improvement through the use of WAN acceleration in this case as well. The unique thing that we've provided, as I mentioned, is you look at the deployments that I've just talked about. The real advantage that we have here is that we can actually attach the WXA directly to our next generation firewall. So as you navigate through the interface of our firewalls, what you'll see is there's a WAN acceleration tab that is populated as part of SonicOS 5.8.1. In this case, once you attach one of the WXA appliances to the firewall, a lot of the configuration is done for you. The devices are auto-provisioned, both either hardware or software. The licensing management is done for you. You can do firmware updates and configuration management. You have some health check probes in case the WXA fails or something happens to the VPN tunnel. The idea here is that we're consolidating the management of application intelligence and control, deep packet inspection, WAN acceleration, VPN, and a lot of other useful security functionality that traditionally might take multiple devices to achieve. In the case of TCP acceleration, which is the primary method of doing acceleration for us, the idea here is that once you apply the two devices, there's a simple checkbox that you would enable, and then all of the TCP services that we can accelerate would be accelerated. The idea here is that it provides a lot more flexibility and ease of use for the administrator. As you can see from the pull-down menu, there's a couple of different options that you can enable. As the administrator, you do have full control over what does get accelerated, so you can go in there and configure those options as well. We do the same thing for Windows File sharing accelerations. We can extend the WXA as part of the domain and then map the share resources across the VPN or MPLS circuit so that when the user goes to access data, they're actually accessing the data locally, not from the remote server, i.e. they're speeding up the time it takes to actually receive the data when they're actually going and hitting // file share and then the file resource that they want to hit. Then finally, the last but not least is the ability for us to demonstrate and qualify the benefits of WAN acceleration. So as part of this, we have a lot of on-box reporting capability that shows the benefits of introducing WAN acceleration, into the network. In this specific case, what we're showing is about a 69% reduction in data, which equals out to about a 3.3 increased factor of getting the network bandwidth back in order. And so what I mean by that is if you look at the gray line that's here on this chart, it actually shows that this is what would have been sent with WAN acceleration not enabled or not available. And then the blue line here basically shows what is actually sent of the link in this case. So it's basically giving you kind of here's what you would have sent and here's what we did actually send. And the difference or the delta between the two is what we're showing as the percentage of increase and the WAN capacity increase factor as well. Just a quick high level on what I refer to as why the SonicWall solution is a little bit better than what we're seeing from the competition and why and where our advantage is. There's a couple of really key advantages that I wanted to point out as we go through the final part of this presentation. It's really around deployment, configuration, management of the actual WAN acceleration solution. Again, if you think back to the graphic I'd put up, is that the WAN acceleration device does not sit in line of the network. So we're not going to be a point of failure when you go and introduce WAN acceleration to the network. We're in a one-arm mode, which is unintrusive to the network. And so if something were to fail, basically all traffic would still go through and all traffic would still traverse through to your remote and branch offices. Configuration, again, we auto-provision the devices, so it's a very easy way to get the WXA devices up and running. It's not as complex. There reduces the chance of errors being introduced into the network. Again, manageability is a key thing. It's integrated management. There's not a separate management interface for this. It's directly done through the firewall. And then the final one that I'll hit on is the security aspect of this, is that we don't have to worry about not being able to scan the traffic that's coming through onto the WAN acceleration appliance. We can actually scan that traffic using our DPI engine to, again, improve the security of the network. Whereas if you look at what some of the other vendors do, you have to decide, do you want to put the WAN acceleration device inside the network, do you want to put it outside? And there's some potential issues with doing either one of those. And so in our case, because again, we are an out-of-band device, as traffic is traversing through one of our NSA appliances, the traffic would actually get scanned through our DPI engine before the traffic was sent down to WXA. What that does is it leverages our deep packet inspection technology, so intrusion prevention, anti-malware, all of the app intelligence and control capability. And if you look at what the traditional vendors had put in place, it's really, where do I stick this thing? The traffic coming out of the WAN accelerator can't be scanned by the DPI engine because it's actually been modified by the WAN acceleration device. If I stick it outside the firewall and I terminate VPN there, then I have some trouble with, well, how do I actually, do WAN acceleration for VPN traffic coming through? So there's a lot of challenges when it comes to being able to introduce WAN acceleration into the marketplace. What I wanted to do was just kind of finalize a few thoughts for you guys as you're thinking about what I've talked about here this morning, and I want to run into a quick demo in the last couple of minutes before we open it up for the additional Q&A. As part of what SonicWall is talking about when we refer to secure network optimization, it's a combination of a couple of things. It's a combination of what we're doing with app intelligence and control, and the combination of introducing WAN acceleration. The benefits are quite a bit in that, again, we can reduce the amount of data that's sent between your remote office and branch office locations. We can easily block undesirable applications from any location on the from any internet location on the network. We can bandwidth manage applications, so we can really limit what people can utilize as P2P and streaming audio and video. We can improve the security for our deep packet inspection scanning. Again, a key attribute to this is we have on-box reporting tools, both for app intelligence and WAN acceleration. So we can improve or identify efficiencies that will allow the network administrator to improve the network performance. And finally, consolidated management. So we have the ability to provide all of this functionality out of a single interface. So you don't have to go and learn something completely different. The app intelligence, DPI scanning, WAN acceleration, and VPN are all done directly out of the interface of the Sonic Wall. So, again, there's a lot of benefits to, what we're talking about is secure network optimization. So, just quickly, if you have any additional information you want to go and look at about the WAN acceleration solution, you can always go to our website at sonicwall.com, click on the product section, and then take yourself to the WAN acceleration part, and it will provide a lot of good detail, things like data sheets, solution briefs, and white papers as well. So what I wanted to do was just take the last couple of minutes before we open it up for Q&A and just show you guys a quick demo of WAN acceleration and what the benefits will be from the user perspective, not from the administration, but what the user might actually experience. And so what I did is I actually set up a couple of firewalls in our lab that actually run VPN between the two of them. We actually inserted a device between the two that provides about a 7 meg connection with about 50 milliseconds of latency that really provides kind of a true test for WAN acceleration in this case. So what I'm going to use to actually transfer the files back and forth is just an FTP client because it's an easy way for me to demonstrate kind of the benefits of utilizing WAN acceleration. What I did is created about 6 different copies of the same presentation, but I modified them either in the front, middle, back. I did it in a couple different ways. So I modified them using either adding additional slides, adding additional text, or adding additional what I refer to as just photographs inside of the presentation. So what you'll see is that the first time that I copy the file across, the file transfer speed will be about 200K, 170K. It's going to take approximately 35 seconds for this specific application to be transferred across the network in this case. And so we'll give it just a couple of seconds here to transfer across. And what we'll see is that once the deduplication and protocol optimization has taken place here, meaning the first copy has gone by, and now I'm sending redundant data, which you'll notice is that will improve the performance of the actual data transfer between, in this case, the remote office and the corporate office. And so if I transfer the same file back and forth, what you'll see is that the improved efficiency of actually utilizing WAN acceleration. So instead of taking 34 seconds, this time it took 7 seconds. Well, what if I have a very similar, a file that's very similar, but the data is slightly different inside of here? So I'll transfer a different version of that same file, and what you'll see is that the file transfer speed still improves. And so we're seeing, about an 8-second improvement, or 8 seconds to actually transfer that same file. So if I transfer even a bigger file, in this case it may take just a little bit longer, but again, the improvement is still there, and we're still improving the performance for which the user would actually see the traffic transfer coming back and forth. In this case, it took about 8 seconds. On the previous webinar I did, one of the questions I received from the audience is, well, what if I copy a file backwards? So I take the file from the remote location and I copy it back through, what will happen? And so in this case, I'll copy the file backwards, and what you'll see is that we're still providing improvements even going in the other direction. So it's a bidirectional configuration that we're talking about when we refer to WAN acceleration. Again, this is just one example. There are a lot of other applications that benefit from WAN acceleration, but using FTP allows me to kind of show you from the real world exactly how long it takes to transfer without WAN acceleration and the difference between with acceleration. So what I'll do is I'll turn it back over to Nathan, and he can open up for any question and answer session for the last 14 minutes or so.
Okay, thank you, Matt. So I have a couple questions that have come up from the audience. One of them is it says, how do I know what applications to manage? So I believe this is referring to in the application intelligence control. There's such a myriad of applications out there to try and bandwidth manage and control. What are some of the best ways or some of the best practices to understand which ones you should try and manage?
I mean, that's a great question. What I don't When I refer to, when people ask me this specific question, I always ask what the policy is for the organization. And really the policy that the organization has in place is going to dictate what types of controls you want to put in place. Some organizations have a real, lenient policy where they allow, streaming audio, streaming video, P2P, or you go to the far right where, some organizations allow you to get to 3 websites, for example, and anywhere in between. And so what I always tell people is it's going to depend on, what type of policy you want to put in place from a corporate standpoint. And then from there, what I always recommend is that just look at the on-box reporting and see what's actually happening. And then from there, you can actually look and say, okay, I know that this application is not business critical. I'm going to go and write a policy that says that Matthew Deacon can't use this P2P application, or Matthew Deacon can't stream the Monday Night Football game from ESPN. And so, it's just going to depend, I think, on how the company wants to deal with the issue at hand, essentially.
Gotcha. So I think it just made me curious as a follow-up question, and this isn't from the audience, this is just me thinking about that as you responded, is, so, I mean, if I'm either, Mytech trying to work with a customer or an IT person trying to look at their bandwidth, are there ways in which you can look at the firewall to see what traffic is being used on the connection to be able to say, oh, I see that, I don't know, ESPN is taking up a lot of traffic because it's fantasy football or something like that? Is there a way to be able to understand that kind of what applications are actually being used so you can try and write policies as opposed to guessing what policies to write?
Yeah, so what ends up happening directly on the device is you can do that. So you can go to the real-time monitor in the device itself, and in this case, when it pulls up, it'll show applications. All right, hold on. Sorry, the app flow monitor. And what will end up happening is you'll see the different applications in use. In this case, it was the last 60 seconds, but you can scroll through here and see which applications. In this case, it found BitTorrent, some Google software, Kerberos UDP, and other applications. And you can go in here and you can then figure out what's happening. So you can filter this data out via setting up filters. And so you can add a filter that says, I want to look at these different applications. And then you can filter it down to a specific set of users directly from here as well. So, or you can come at it the other way, and you can look at the users here, and you can say, and you can filter out, you can create a filter view that says, what applications are these specific users using over that specific period of time? And since it's on box, we have a certain amount of data that we can store, or you can offload this to like a NetFlow collector, and they'll be able to provide some additional information as well. This includes things like URLs, who initiated the connection, responders, threats, VPN, devices, content. So there's a lot of good information and tools, as I mentioned, that we can provide directly from the interface of the device that will allow you to kind of pinpoint what trouble or what inefficiencies you have on the network.
Fantastic, thank you. That's exactly what I was looking for. Is I thought there was a way to be able to check that. So thank you for that response. A couple more questions here from the audience. One of them is relative to the WAN acceleration, and I believe I know the answer to this, but I'd like you to respond with regard to what are the best types of traffic to get accelerated. You give an example of the file transfers, but what about Citrix or terminal sessions, things like that?
So what for the WAN acceleration specifically, we really benefit for 2 specific, I don't want to say protocols, but a lot of TCP applications. So FTP, any type of internal web application, certain types of database applications. We've seen success with things like server replication software, database backup software, and other types of software that really utilizes TCP as the communication protocol. Where we don't see a lot of benefit and where we don't provide a lot of value is if the protocol itself or the application itself either is already compressed, meaning that it has some sort of compression technology that it uses natively, or if the application is already encrypted. and that happens to be the case both for something like Citrix, where natively Citrix actually uses its own proprietary compression protocol and some form of encryption. So for that specific use case, we don't provide a lot of benefit for that specific type of application. For RDP, however, we can provide some benefits to improving RDP, things like remote printing and other types of functions from RDP specifically. But again, if the RDP session is using some form of native encryption or compression, then the benefit is not going to be there for them. And part of the reason why is that if you think about if you take a file and you take a zip program and you zip that file up, right, you've already received a lot of the benefit. If you take the zip program and you try to zip that zip file up, the benefits that you're going to see are pretty minimal. And we take the same approach when we're talking about WAN acceleration, is that the applications we're looking at are really in clear text via TCP. The other thing I will say is that a lot of it depends on the actual application itself, meaning that if the application you're utilizing is more of where the traffic is identical or very the same, then you're going to see a lot of benefit from utilizing WAN acceleration. If the traffic is a one-time request where the requests are always different, then the benefits, whether it's SonicWall or other technologies, are not really going to be there. Yeah, we can provide some compression and some protocol optimizations, but the real benefit kicks in when you start talking about doing TCP-level byte caching and deduplication, is that we're not sending the entire payload of data across those different links. So hopefully that helps out and gives you guys an idea of some of the technologies, applications that can benefit from WAN acceleration.
Sounds good. Thank you for that. There's another question here from the audience, which is, what are the requirements for being able to leverage both the technologies you talked about? Is this does it require new hardware, new device? What are the requirements to be able to leverage this technology?
So in our case, and let me just jump back to the diagram I had here earlier in the presentation. The requirements would really be twofold. Any next generation firewall appliance from SonicWall, so any of the later Rev TZ running 581 NSA or E-class NSA devices would be required to take advantage of application intelligence and control. So, any of the E8500 NSA devices or even TZ, those would be able to take advantage of all of what I'm talking about here from the app intelligence and control standpoint. And then for WAN acceleration, again, as long as you're running one of those later versions, they would be able to have the WAN acceleration device attached to them as well. So any low-end TZ100, 200, and 210, all the way up to the E8500 has support for the WAN acceleration technology. So if you're running what we refer to as any of the Gen 4 or even previous generations, like the lower-end TZ180, 190 Pro boxes, those have very limited capabilities for a lot of the app intelligence, but they do not have any kind of capability to interface to the WAN acceleration devices. Those would require some of the later generation appliances from SonicWall. And the minimum that I would tell people, for app intelligence and control, it can be used off of one box. For WAN acceleration, it requires a minimum of 2 boxes, but we can support in this, if you look at the diagram, more of a many-to-one configuration where you have many remote offices that connect back to a corporate office.
Very good. And so you alluded to it a little bit, but I guess I wanted to offer some clarification. There's another question here from the audience about the application intelligence control on these current generation appliances. Down to what series? You mentioned the TZ, so the TZ210, the 200. Are those both able to do some of the application control that you were discussing, or does it start at the 240, or where's that line drawn?
Yeah, so for that case, the 210 and higher are really where you're going to see the benefits of app intelligence and control. And a lot of that comes with the fact that the 210 and higher have the onboard reporting capability or the visualization, whereas the 100 and 200, well, they have some functionality through the signature databases built in. They don't provide a lot of the tools because of because it's low-end hardware, so there's not the horsepower for us to be able to provide the on-box supporting. The 210 and higher are really where you're going to see a lot of benefit from app intelligence and control. What we've seen is a lot of our customers that have looked traditionally at the TZ product line for their network had really found a lot of benefits moving to something like an NSA 240 or even in certain cases an NSA 2400 because they received a lot more reporting, a lot more benefits out of the app intelligence and control on those two platforms versus the TZ product line.
Very good. And then the last thing I wanted to bring up, this isn't from the audience, this is just a question about, what are the main motivators for, leveraging this technology? And I remember you mentioned in the beginning, but as companies, what's really driving the utilization? I mean, to buy a new next generation firewall or purchase, WAN acceleration relative to bandwidth. I mean, what's really the kind of the driving business case for this technology?
So I would say, from the next generation firewall standpoint, there's a couple of real business benefits of why companies are looking to move to an NGFW. Is that the traditional firewalls, we knew it, a couple of years ago, stateful packet inspection, which allow you to basically look at the source and destination at the port and protocol level, is really not up to the challenge of knocking down a lot of the sophisticated threats that we're seeing today. The problem that's being posed to a lot of the, basically the internet as a whole and companies, varying from small to large, is that the hackers are more sophisticated than ever. They're backed by, lots of money, more, bigger crime organizations. And really the challenge is that you need to be able to scan, all packets of any size, regardless of file, regardless of port and protocol. And the challenge of doing that with an older version firewall is that you don't scan the payload. You provide zero value to actually scan for those increased threats. And so what we've seen is a migration more towards next generation firewall from a security standpoint, because we can provide the intrusion prevention scanning, we can provide the anti-malware scanning, both inbound and outbound. We can inspect over, regardless of port and protocol, we can inspect encrypted traffic via SSL, which is also important. And, we provide a lot of benefits over, again, what stateful packet inspection devices have for being able to identify applications and then provide bandwidth controls over those as well. And so I would say it's twofold. One of it is the security aspect needs to increase regardless of whether you're a small site, big site, have multiple sites. The biggest thing is that hackers are looking for the weakest point in the network. And if that happens to be a branch office running a stateful packet inspection device, they're going to use that as a method to propagate back into the corporate infrastructure. And then vice versa, a lot of the companies are looking to control and identify the different applications in use, really around productivity. And so to gain this productivity or to improve the productivity gains, you need some way to identify those different applications. And then from there, WAN acceleration is a technology that's been around for quite some time. And really the business benefit is that if you have an office that has limited bandwidth capabilities for whatever reason, whether it's because of money or because of infrastructure, the only way to improve the connectivity and improve the end user experience is really through WAN acceleration. There's no other solution that can provide that. If your bandwidth is capped at like 1.5 megabits, you're not going to get any more bandwidth out of that. So the only way to provide an improved user experience is to improve how that bandwidth is being utilized off of that slower connection. So hopefully that answers the question you posed. So.
That does. So thank you very much. And since we are at our 12 o'clock stop, I want to thank everyone for attending. We are going to stop the broadcast at the time. I want to thank Matt for being our panelists and subject matter experts, and everyone else for participating in our Mytech U, the October webinar edition of 2 technologies that can improve productivity 10% or more. Thank you very much, and we'll be able to connect with everyone else offline if there's any questions we weren't able to get on this broadcast. Thanks a lot.
Right,
have a great
day, everybody.